In this episode of the Data Exchange, I speak with Ameet Talwalkar. He is the co-founder and chief scientist at Determined AI. He is also an assistant professor in the machine learning department at Carnegie Mellon University. Ameet Talwalkar, co-founder and chief scientist at Determined AI, as well as an assistant professor at Carnegie Mellon University. Welcome to the Data Exchange podcast.
Thanks, Ben. It's great to be here.
And full disclosure, I am a proud advisor of Determined AI. All right, so Ameet, you, Neil, and Evan founded Determined 3 years ago.
Mhm.
And I had Evan in the podcast a while back, just when the open source announcement was made. So just to reinforce to our audience, what was the thesis when the company was founded? And why was the software eventually open sourced?
Yeah, so the thesis when we started is pretty much the thesis today, which is just that sort of model development is incredibly difficult in production. Kind of going from research to production is more painful than it should be, and it requires a sort of incredibly wide spectrum of expertise, from math to engineering to applied domain knowledge to very expert sort of systems level knowledge. And it's something that pretty much no one person can do all of, but it's something that's kind of required today to actually get an ML model into production. So sort of with that pain in mind of a lack of infrastructure, lack of software tools to kind of help ML engineers kind of get their models out the door, we saw a real need to kind of basically, right now, or when we started the company, there were things like TensorFlow that were emerging and that were getting started. Things like PiTorch, those things are great. They've really taken off, but there's a lot to do between TensorFlow or PiTorch and the actual hardware, whether it's a GPU or whatever sort of specialized hardware is going to be coming out or is coming out these days. There's a lot to do to connect those two, and kind of being the glue to connect a very sort of high level expression of the application the model you want to be training, to actually running these models and managing these models, logging them, collaborating, sharing your hardware and things like that. These are things that just didn't exist. And so that was a thesis back in 2017. It sort of remains the thesis today. In terms of
So Amit, just to clarify, in the context of Determined, maybe not necessarily of your research at CMU, when you say machine learning, we're really talking deep learning, right?
Right. So I guess the second point here is that, I think generally machine learning, deploying it is challenging, but these challenges are all really multiplied and kind of made that much harder in the context of deep learning, just because the hardware is more expensive, the data is a lot larger, the total time to train, the number of hyperparameters to tune, all of these things are bigger and more challenging. So the problems are exacerbated. And it's also kind of, it's one tool in the toolbox of machine learning broadly, but it's one that's very popular today and has had real success. So kind of when starting the company, we decided in order to be focused and kind of focus on the hardest problems that we think are highest impact right now, we decided to focus on deep learning. Yeah, so that's right.
So again, I asked Evan this question, but let me ask this to you as well. So why did you folks decide to open source the software recently?
Yeah, I mean, so the general thought of open sourcing was something we thought of from day one. Evan might have used, Evan often says this, and I would agree that sort of open sourcing is in our DNA. We met in the AMP lab. We were heavily involved in the Spark project, saw the amazing benefits of growing a community through open source. And so it was something we always thought we would consider. Kind of what we wanted to do, though, was partially, I'd say that there were two reasons. One, we wanted to kind of build something that was ready for people to use before open sourcing it. We wanted to work with design partners, kind of understand the problems better, and have something that was ready to be kind of more widely consumed before open sourcing it. And then two, it became very clear that the machine learning community is more and more moving towards kind of demanding open source. The tools that a machine learning engineer, and these are deep learning engineer, and these are our target users, they pretty much demand open source, right? It's what they're looking for. They want to get their hands dirty. They want to play around. They want to just be able to see what something is, rather than having something be, handed to them by their manager or by their company from the top down sort of So from a business perspective, as a way to kind of get users to understand what we're offering, it kind of needed to be open source. But it was also something that kind of is a very natural thing for us to do, given our background and kind of our previous experience building software.
So you're now weeks and a couple of months, I guess, into this
Yeah, I
open
think it's about,
source
yep,
journey.
it's been,
And what are the initial observations?
I mean, it's been really exciting. Really, I think we've had a really, really good reception. Right. Granted, it was there's a lot going on in the world right now, things that are more important than open source software. So that's with that in mind.
The Slack channel is quite active, actually.
Yeah, Slack channel is active. The GitHub is active. Kind of the number of users, people who are kind of just experimenting with the product, using the product. There's a lot of activity. I think we came out. We started right during iClear, or during the virtual iClear. And for those of you who don't know, that's one of kind of the leading machine learning conferences, largely focused on deep learning related things. Right when we released, we were kind of the number one, what was it? I think it was on Reddit, like the machine learning channel on Reddit. We were the number one kind of post. Lots of feedback, lots of questions, kind of about people were very. It seemed that we really struck a nerve in terms of kind of what I was talking about. The lack of infrastructure, the pain that ML engineers were feeling in terms of trying to actually develop their models. They were focused, they had to deal with DevOps. They had to deal with things that they either didn't know about or they didn't want to deal with in order to actually do the things they wanted to do, which is to develop models. So folks were really excited. There was, as I mentioned, top of Reddit during iClear, which is interesting. Lots of questions, lots of support questions, many of them on Slack, as you mentioned. There were a bunch of product requests, which is great. Some of them were things like, when are you going to support Windows, which is not necessarily something which is actively on a roadmap, but it's cool to see that, a wide range of people are interested. But there were also a lot of product requests, which we viewed as good validation for us, in the sense that these are requests that are actively things that we're working on. They're in flight for us, things that we're hoping to land this quarter. Things like, Kubernetes support, better interfaces for users with existing models, say in Keras or PiTorch, integration with ETL systems, things like Pachyderm or Spark, or with model serving systems like Selden. And again, that just kind of to put us in perspective, very, very, at a bird's eye view, you can view machine learning, or the general machine learning workflow, being in kind of three stages. What you do before training, ETL, the data collection, ETL, the actual training of these models, and then the deployment of these models. And as the name of our system is called, the Determined Training Platform, we sit in the middle as part of the training part, which we think that there's some real pain points there. But of course, it's important that we kind of connect with the other two components. So understandably, integrations with the kind of leading systems, or the leading services, open source services, especially before and after, are kind of important, and something that people are asking about.
So what's the mix, Ameet, in terms of, because the three founders had background somewhat in academia, right? And you're still in academia. So when you folks open sourced the Determined Training Platform, what was the mix? Was it industry versus research labs versus?
Yeah, it's kind of, whether it's industries at big tech company, or engineers at big tech companies, or sort of undergrads working at projects at universities, was sort of a wide range of folks using it. And I guess I would say that's another reason that we were excited to open source, is the sense that, right, we don't necessarily expect to be selling software to undergrads working on class projects, right? But at the same time, we think that what we offer is really valuable, both to individuals and to teams. And as a growing company, we both think we have something really valuable to offer to people today, but we also think to kind of improve that product and grow on it, getting feedback from the widest user base possible is kind of really important to us. Right, so users, small, big companies, individuals, or teams of students at universities, it's been kind of a wide range of kind of users on a wide range of problems, which was kind of our hypothesis, but also good to see.
What about Ameet, in terms of how would you say this? I guess they're not use cases, but kind of application area. So what's the breakdown between computer vision and language and structured data, time series, that kind of thing?
Yeah, so I don't have
anecdotally, at least.
Yeah, anecdotally, we've seen all of them. As you'd expect, there's a lot of applications on computer vision or NLP, because those are some of the the applications that we're seeing are following kind of the applications where people have seen success in deep learning. But it is the case that, for different applications, different features that we offer as part of our integrated system are potentially more compelling to different users. So for instance, for folks who are, we work with, we've seen some folks in the autonomous vehicle space use our product. And those folks, they have a lot of image data, right? So they're working with models that have been developed over the last several years, given the influence and impact of deep learning on computer vision. And kind of a big challenge for them, one of the big challenges for them, is that they're collecting huge amounts of data every day, and they need to train their big deep learning models quickly. So distributed training is something that's really important for them. They have good models, they just need to retrain them from scratch very quickly before that data gets stale. So we have very easy to use and state-of-the-art performance-wise distributed training, and that's something that folks in computer vision working in autonomous vehicle data are very excited about. As another example, right, we have one of our customers is in drug discovery, right, and that's also computer vision, but it's sort of a different set of problems, right? You're not trying to find faces in an image or typical object. It's kind of a different sort of use case, and so they're not just taking off-the-shelf models and running them. Not to say the autonomous vehicle folks are doing that too, but the transfer is larger. There's a bigger delta in that transfer. And so they're thinking more as well about, distributed training is important because they have a lot of data, but designing the actual architectures, hyperparameter search, neural architecture search is important because they need to come up with models that actually work well for their data. And so our hyperparameter search functionality, for instance, is sort of really useful.
So that's interesting, actually. So the software open source project is called Determined Training Platform. So the key word here is training, but you alluded to something that I want to drill down to a little bit. So for a typical engineer, it seems like based on what you're describing, training is actually doesn't necessarily mean training from scratch. It could be tuning a model that you found somewhere else, or transfer learning. So which of these notions of training does determined support?
Right. So we kind of view, you're absolutely right. Part of the reason we think the training component of, if you're thinking about the machine learning workflow as these three components, we think that the training component is a very broad one because it encompasses a bunch of different workflows. It's not the narrow definition of let me train a single model from scratch and be done. There's all the components you talked about, sort of hyperparameter optimization, transfer, warm starting. There's also things like collaboration, right?
Well, Ameet, nowadays too, people will see a paper, they go to archive, then they notice there's a link to GitHub, but then they try to use that model. It's supposedly trained, but it may not work off the shelf for them. So
So that's right. So
how does determined help in that context?
Right. So that's kind of another one of these sort of one of the DevOps challenges of deep learning in particular, machine learning in general, but I think deep learning is exacerbating this issue, is one of reproducibility and collaboration. It is, for a variety of reasons, reproducing results that are, the output of deep learning models is very challenging. This is a huge issue in research these days. I think neural architecture search, which I think we're going to talk more about later, is kind of one of the canonical areas where reproducibility is kind of a major issue. And actually, the first paper that I worked on, I guess a couple of years ago now in this field, was really focused on that because it was sort of something that we thought was sort of a big problem. But kind of anyway, that's an aside. But reproducibility is hard. If you can't reproduce something, it's really hard to make progress. If you can't reproduce something, it's really hard to collaborate with your neighbor or with your peer. And so, right, what you ideally want to do is run something in such a way that it's sort of containerized. The code is you have access to all the code, you have access to all of the data, but you also snapshot, the third-party libraries that are being used, the random seeds that you're using to figure out how you initialize your model, how you split your data, right? So all of this metadata needs to be captured, and ideally, you as an end user just want that to happen automatically, and that's pretty much what Determined does for you, right? And an example that I think often about is kind of, and this is kind of this ongoing theme, that actually using machine learning in practice today requires just this really wide range of skills. I think about my students at CMU. They're some of the smartest people I've ever had the pleasure of working with. They're more interested in modeling and math. They're less interested in sort of, CUDA kernels or containers or Docker. But to really, to run large scale experiments and to have reproducible code, even to publish papers these days, all of these things are kind of becoming more important. And in production, if you're actually wanting a model to be in production for an industry where your model for your company where the model is actually core to your business, this is even more important, right?
Or where you have regulators who might ask questions.
Exactly.
Right.
And so kind of seamlessly being able to capture this metadata to allow you to reproduce that model, whether it's today, tomorrow, 6 months from now, or to collaborate with a new colleague that's joining. These are things that are kind of, this metadata is automatically sort of captured by us by the product kind of in a seamless way. So you as a user can focus on your modeling, not on kind of storing and capturing this metadata.
So Ameet, if you were to characterize the determined training platform target audience, I guess, so it's not necessarily the people who are building these cutting edge models. They're the people who want to use these models, right? So if I'm a user of a model, so I take a model from somewhere else and then I try to fine tune it. How does determine help me in that sense of the fine tuning step?
Right. I mean, so I would say it's the one, typically, if you're starting with an architecture or eventually you want to do architecture search or something like that, you still are applying it on your data. And typically you're going to have, you might have a lot of data. So one way it helps is just sort of at scale, seamlessly at scale. If you want to do distributed training at scale, it's very easy and it's very fast. If you need to tune the knobs of the models that you're using, we have state-of-the-art hyperparameter search. Again, and the example of kind of the drug discovery example that I mentioned is one there where when you're doing transfer learning, it typically doesn't work seamlessly. You have to use some sort of tuning to kind of to get the fit that you want. Again, both for individuals and teams, to deal with experiment management, log tracking, metrics visualization, reproducibility, dependency management, and just and collaboration in general, these things are kind of done automatically for you, kind of behind the scenes. And then finally, we kind of connect with the hardware that you have. So whether you're on-prem, whether you want to use GCP, whether you want to use AWS, we're not locking you into any hardware. You can install it or run it on the cloud as you wish. As new hardware comes out, you can also kind of do that sort of thing. But basically, in a nutshell, all of these things come down to, if you are experimenting on your laptop with a small amount of data and a toy model, that's great. But when you want to kind of solve real problems at scale, both in terms of the data, the size of the model, the size of your team, the size of your hardware infrastructure, all your problems get significantly harder, and you need infrastructure beyond just, say, vanilla TensorFlow to kind of be able to be successful. And those are the sets of problems that we're kind of dealing with.
So before we move on to your work at CMU, two last questions on the
Sure.
determined training platform. The first is, what's the relative breakdown between PiTorch and TensorFlow that you folks are seeing? And then number two, in terms of geographic areas of people using the open source project, is it mostly in the US?
So the first question is a very heated one in terms of people in their camps. I don't have a precise answer. Thankfully, I will say that those are the two things that we have very, very passionate active users in both camps, and we support both of them as first-class citizens. I don't have a clear answer, but I would say that both of them have very, very large user bases that are excited to use determined. To be very clear, we're not trying to compete or replace those things. We want to say that you come with your PiTorch code, you come with your TensorFlow code, and you use that code, and you can unlock a bunch of other functionality by running it as part of determined rather than not using determined. But the point is that both of them there's enough use cases for both of them, and a huge enough user base for both of them that we're supporting both.
And by the way, you alluded to this earlier. A lot of this is when you get to use deep learning quite a bit in a team setting. Efficiency matters as well, right?
Right.
Yeah.
I mean, I would say, part of our hypothesis about open sourcing, though, was that while we think that there's some really important features that get unlocked with teams with our product, we also think that we really do help an individual user. Distributed training, hyperparameter optimization, but still a lot of the metadata tracking, that stuff is very, like reproducibility is still very useful for an individual, right? I know that, I mean, I tell the story a lot, but when I was in grad school, sure, I wasn't working on deep learning models, but it was still the case that my way of being reproducible was after I ran a bunch of experiments, just writing down in like a notebook notes to myself about what I did, so that 6 months later I could hopefully look in that notebook and remember what I did. And that things are too complicated now to actually be able to do that. So certainly we think that, you know, for a team, what we offer is very, very compelling. But our hypothesis was, and I think it's starting to be borne out in terms of the reception from open source, for individuals as well, there's a lot that we offer.
So just to follow up, so it's still early days, but are you seeing a lot of non-US users of the?
Yeah. So again, I wish I had better. We have that data. I don't have it on the top of my head. I know we are certainly seeing users across the world. I think our CTO is hoping.
China. I'm interested in the China angle. Yeah.
I wish I don't have a specific answer. I would say one thing, that we are very excited the fact that, well, you know, the pandemic is a scary thing, and there's lots of people suffering for a lot of reasons. One very, very, very small thing that is helping us in the sense of COVID is that we can give talks around the world without traveling anywhere. So obviously not to detract from how horrible COVID is, but given the fact that there has been interest around the world, we're starting to think about giving talks around the world about our product, because we are seeing pockets of users in Europe and other places as well.
Awesome.
But I don't have specific numbers about that.
All right, let's pivot to Carnegie Mellon, where you're on the faculty of the machine learning department. So right now, I associate you a lot with neural architecture search. So we can talk about that, but broadly speaking, so what are the areas that you and your students are interested in?
Yeah, so I mean, broadly speaking, my interests just as a human being professionally are kind of democratizing machine learning. So it's sort of from that very bird's eye view that kind of motivates the reason I've been involved with Determine, why we started the company. It also motivates my research at CMU. But with, more specifically at CMU, neural architecture search is something I've been working on a bunch. Federated learning and meta learning is another area. And a third area is kind of interpretability and transparency for machine learning. And again, I view all of those areas as, broadly speaking, under this umbrella of democratizing machine learning. So neural architecture search, we'll talk more about that, but federated learning and meta learning is, how do you learn given hardware constraints and given where the data is actually being collected, and how do you, from a modeling perspective, take advantage of the fact that you're not learning one model, but you're learning, thousands or millions of models that are somehow connected in some way. And then from the transparency, and also I've started to do a little bit of work on fairness as well. From the transparency and fairness point of view, I think it's obvious that to democratize ML also means to use it safely. And in order to use it safely, we need to think about things like bias and, not just consider machine learning models as black boxes, but actually understanding what decisions they're making so we can uncover those biases, potentially fix those biases, or even if we can't fix those biases, at least be aware of them so humans can intervene and kind of fix issues that arise. So those are kind of, a broad set of the things that I'm working on.
So you actually gave one of the best talks I've seen at O'Reilly AI conference when it still existed on neural architecture search. You gave an overview of what it is and what it is that people are doing in that field. But so to begin with, what exactly is neural architecture search? I think the phrase kind of describes it, but what is the reality of it right now, I guess?
Well, so maybe I'll first define what its stated goal is, and then what the reality is. Does that sound good?
Yeah.
Yeah. So the motivating problem is that deep learning is becoming more and more pervasive. We've seen more and more of the potential impact of it on real applications. But in spite of that, actually designing neural networks is an incredibly opaque and sort of ad hoc process that a handful of highly trained experts are able to kind of perform, and that nobody else is able to really do. And so kind of automating the process of designing a neural network for your particular task is really the stated goal of neural architecture search. And it kind of what the name, you're searching for a neural architecture for your specific task. So that's sort of the precise goal. And I think it's pretty clear that it clearly falls under the umbrella of kind of democratizing machine learning or automating machine learning, auto ML. So that's the goal. And part of the reason people are super excited about it is because this is a really in order for everybody wants to be using this technology, if you don't understand or don't have the ability to design architectures that work for your problem, then there's a fundamental barrier there. So there's real excitement around it. The reality is that there has been some interesting kind of preliminary work in this area in defining the problem and in using the initial, the first or second generation NOS methods to get state-of-the-art performance on existing benchmarks. But the reality is that the work so far is more kind of incremental. Instead of fundamentally discovering new architectures, discovering the next ResNet or discovering the next convolution, what people are really doing is saying, I want to fine tune a pretty detailed handcrafted architecture on a new problem. And that fine tuning, it can be useful it can be useful and it can work nicely as new architectures are designed from scratch. You can then refine and fine tune them using existing NOS methods and get better results on existing benchmarks.
So Ameet, what you just described there of fine tuning, would you consider that at the level of practical today? In other words, if I take ResNet and I say, oh, ResNet doesn't actually meet my SLAs for my particular application, now I will use NAS to fine tune it. Is that at the level of that practical?
So sort of, yeah. So there's I would say that the two practical benefits that people have seen in research, and like there's also this.
No, practical, man. Practical industry.
Practical industry, I would say that there's a little ways to go.
Okay.
I would say determined we're pretty far ahead in this aspect, but there are both kind of research and kind of statistical and algorithmic questions, but then there are also engineering questions of actually making this feasible for people to actually use, and there are barriers in both of them.
I see.
Even on the more narrow fine-tuning sorts of problems. And again, I should be really clear. I think NOS is a very promising direction. It's not that I don't mean this in a negative way, but there is a gap in terms of stated goal and reality of where we are. But you mentioned something interesting there about like, if a model doesn't meet my SLAs, the kind of two areas where practically, at least in the research community, that people have made progress for NOS are kind of just on an unconstrained problem, but trying to improve on a benchmark. I want to do better on Safar 10 or on the Penn Tree Bank benchmarking data set. The other area, and this is a little bit more recent, but it's starting to look really interesting, is on like constrained NOS problems, where I'm not just trying to optimize accuracy, but I need to devise a model that fits on a new remote device, or it needs to have a latency of under 100 milliseconds or whatever it is. And new NOS methods, at least in research, and these are very new methods, have been shown to work quite well for that sort of problem. So in specific for this problem of if I have particular SLAs, I think that is a very promising area where I still think it's kind of, it's not the stated goal of dramatically learning a new architecture, but practically that could be the way forward for kind of learning constraint architectures under constraints that are useful for specific deployment consideration.
So the other consideration here for the audience that listens to this podcast is some of them might read articles like, these days when you train one of these cutting edge models, it may cost you $500,000 in the
right.
And it might take months. So define the notion of search in this context.
Yeah, right. So I mean, I think in the context of neural architecture search, that question is very appropriate, right? There were some papers that came out, I guess, late last year about red AI, meaning kind of quantifying the negative impact on the environment in terms of the amount of energy needed for GPUs to run whatever deep learning procedures that you want it to run, and kind of how put that in perspective in terms of like its impact on the environment. And the original NOS papers and the initial papers that kind of introduced the idea of NOS, while some of the results were interesting, they were kind of the canonical examples used in these red AI papers about the staggering costs of deep learning. So yeah, so the kind of, this is maybe a longer-winded answer to your question, but the excitement of NOS in 2016, when the first papers came out by some folks at Google, was really tempered by the fact that it was just so comically expensive to run these sorts of methods that they were just impractical for everyone other than some groups even at Google. That's changed a bunch, and that's kind of a big innovation in the years followed, was kind of coming up with NOS methods that were solving similar problems, but doing it in such a way that the costs were literally 3 or 4 orders of magnitude cheaper. Meaning you could run the NOS search algorithm or a NOS search method roughly in the same amount of time that it takes to train a single model. So that's not actually answering your question. I mean,
what?
I'm happy
I guess Ameet, as you were talking there, you mentioned Google. So, and yes, I think we associate the reemergence of NOS with Google. So, as far as you know, is there like a NOS success story that kind of like I guess we read stories of DeepMind saving energy
so I
at
think
Google data centers. So is there an equivalent story for
so
NOS?
I think the best success story is in this constrained NOS setting where people, and I think it's folks at Google have used, but I think elsewhere as well, have used NOS to design new architectures for new pieces of hardware, right? So you have a model that gets you an accuracy that you're happy with, but now you need to, you can either prune it after the fact, or you can use something like NOS to find a model that is small enough or energy efficient enough that it works on some new hardware. And folks at Google have used NOS to kind of develop to find these sorts of models.
I see. So it's basically taking a model that's existing and then running it on a more constrained setting.
Exactly.
Yeah. Right. But are there examples? So right now, if you were to predict in 2 to 3 years, what's your sense? Is NOS still going to be a thing?
Yeah, so I mean, I think NOS. I think the field of NOS is like bifurcating, or at least in my mind, it's bifurcating. One area it's bifurcating is going to be in terms of taking the things that are currently working well, which I think are not really actually solving this broader NOS problem of discovering new architectures from scratch, but they have shown to be beneficial in terms of fine tuning or dealing with constrained environments. So one direction is going to be to continue to exploit that direction, come up with methods that are more principled, more efficient, and then coming up with sort of software and just systems that actually allow you to use these in a robust sort of way. And work that came out recently by our group is it's this work called Gaia, which is, I think, along that lines of saying, okay, well, there's a bunch of methods that have come out, a lot of ad hoc heuristics. It's not really clear what matters, what doesn't. Let's come up with a method that's a bit more principled, a bit more simple. We can study it, say its convergence behavior, but also by studying its convergence behavior, by understanding why the model is actually or why the algorithm is actually doing what it's doing, we can also we can use that theory to kind of inform we can inform the development of new, simpler, better algorithmic NOS methods that actually lead to better results in practice. And that's kind of, in a nutshell, what we did with this Gaia paper. And so coming up with simpler, principled methods leads to better implementations, more robust implementations. And I think that stuff in 2 or 3 years will be certainly ready for production. So you should, in the context of, say, determined, the idea of saying, all right, well, you want to train a model, but going back to an earlier discussion we had, training is not just training one model. Training should also maybe inform deployment. So you might be training a model now, but knowing that, oh, I'm training this model because I then want to deploy it on some edge device which has some constraints. So you can impose those constraints as part of the training process. I think NOS will probably be the way people will be doing that in 2 or 3 years.
So the other area that you mentioned that I've associated you with is federated learning. And there, I think at least the people who follow this topic, there seem to be actual success stories in the commercial applications
Yeah,
uh,
absolutely.
and things like this. So what areas are you actively pursuing in this general area of federated learning?
Yeah, I mean, so the area that I have been looking at recently, there's actually a connection between NOS and federated learning that I can mention. But the main area that I've been looking at is the modeling component of it, right? So like the canonical federated learning application people think of is you want to learn a user specific model on a cell phone. So maybe a next word prediction model on your keyboard. And for privacy reasons, you want to keep your data on your phone. I want to keep my data on my phone. But we want to learn models that are accurate. So we want to somehow leverage the fact that we both are typing English, say, and we both are in the tech field. So maybe we type similar sorts of words or construct sentences similarly. But maybe we also, our models aren't exactly the same because we speak differently. We live in different places. Who knows? So this general idea of multitask learning or meta learning, I think the federated setting is a canonical application of multitask learning or federated learning. The idea being you're not training one model in isolation, but you're training many models that are not independent, where they need to be personalized, they need to be specialized, but they can somehow gather strength from each other and improve each other. So trying to understand, coming up with kind of new methods that work in the federated setting to help personalize these federated models. So that's one area that I'm really interested in.
So what's the connection between federated learning and NAS?
Right. So the connection between federated learning and NAS is more of a, right. So this goes to, right. So NAS is generally this problem, right. So it's a problem of trying to discover new architectures, is broadly under the umbrella of AutoML. But you could also think of NAS as really being a subproblem of the general hyperparameter search problem.
Right.
Which is just, again, the idea for not necessarily a neural network, but for any model has knobs that you have to tune. NOS basically is saying that it's specifically looking at neural networks and specific types of knobs, but it is a specific instance of the broader hyperparameter optimization problem. And that said, right, there are general purpose methods that people have developed for hyperparameter optimization, and that's an area I've worked on a lot. We developed the hyperband algorithm over the last several years. In the NOS community in specific, people have developed some specialized methods that work well for NOS in particular. One of them being something called weight sharing. And weight sharing in particular is the insight that, or it is one of the ways that you can get this 3 to 4 orders of magnitude speed up. So it's a pretty powerful thing. We're still trying to understand exactly how and why it works. But the connection between federated learning and NOS is that even though weight sharing was developed for NOS, weight sharing, actually, we've been studying the use of weight sharing more broadly for any hyperparameter optimization problem, and have been thinking about how to apply weight sharing in the context of federated learning to improve hyperparameter optimization for federated learning. So I know that's a lot of buzzwords being glued together, but yeah.
So let's go with basically more on the kind of teaching side of things. So how has the teaching of ML and data science changed from the time when you were in grad school?
Oh gosh, I mean,
of course, deep learning wasn't a huge thing.
Well, I mean, first there's
although you went to
NYU.
You went to NYU, so
yeah. I mean, there's many more professors doing research on and teaching about machine learning. Machine learning is no longer a field. It's not just machine learning. It's kind of pervaded many adjacent fields. So computer vision is largely overlapping with machine learning. NLP is largely overlapping with machine learning. Computational biology.
Some of the most popular classes in a university are machine learning.
Right. So it went from being a niche. When I was in grad school at NYU, it was a great experience. I loved it, but it was what I did during the day, and nobody talked to me about it afterwards. And even my fellow classmates at NYU who were doing other things, we were just kind of isolated. Now it's sort of machine learning is everywhere. So the classes are just orders of magnitude bigger. There's many more of them. But then the other thing is the content is sort of, I wouldn't say changing, but expanding, right? When I was in grad school, machine learning had moved to being very theoretical, right? So it was a lot about proving convergence guarantees or generalization guarantees for convex methods. So and I still think that's a very interesting and important thing to be doing. But there was, I think, an underemphasis when I was in grad school on the practical side of actually using machine learning. And my interest in democratizing ML actually came from when I was in grad school, of thinking, even obviously deep learning and neural networks have existed for a very long time, but when I was in grad school, it was kind of in a depression. It wasn't the resurgence hadn't started yet. But even then, even for non-deep learning methods, it felt like they were just kind of in a box, and they needed to be more widely kind of understood and more widely adopted. But back to classes, it's very nice to see that there are a mix of classes that are, some more theoretical, but some of them are more applied, and teaching about kind of the applied aspects of machine learning, how to actually get things to work in practice, and actually getting your hands dirty with real data. Every class, more and more classes have applied projects now. So, which kind of makes sense, because some of these students are going to go on and continue to do research, but many of these students are going to go on to work at, various organizations that want to do applied machine learning, and they need to have some practical hands-on experience with how to actually do this stuff. So
yeah, probably back when you're in grad school, the ML grad students were using MATLAB, right?
Oh, right. I mean, that's one of my, I was an absolute MATLAB ninja, which was great at the time, but it's sort of it's an absolutely, I don't want to say useless skill, but it's not the most useful skill anymore. Yeah.
Right.
So that's another change. MATLAB has been replaced by Python or TensorFlow or PiTorch.
So speaking of PyTorch and TensorFlow, I think the numbers are clear on the research side that PyTorch is really dominating, right? In conference submissions and papers.
Right. So I mean, you asked that question earlier. I would say that trend is not quite so strong in industry, at least what we've seen. In research, it is very clearly that way.
Right. So then the other welcome trend in recent years in machine learning and data science, both in industry and particularly in universities, is this heavier emphasis on ethics.
Yeah.
Right. So I'm sure that at CMU there's discussion of ethics around ML, right? So for teaching students, right?
Right. Yeah. I mean, I guess there certainly is, and it kind of is related to this point of people are actually using machine. Like for a long time, the goal was to get more and more people to actually use machine learning. Now everybody is, and everyone understandably is saying, whoa, are we using it in a safe, careful, correct way? The answer is often no, and as a result, we need to be, understanding better the limitations, and also educating the people who will be using it tomorrow as to what those limitations are. I think there's a lot more discussion about it. It's a much more important research area. It's getting bigger and bigger. I think that we have a long ways to go, though, to kind of emphasize it further. Right? In the same way that machine learning intro machine learning courses now are using content that's been developed over the last several decades. The sort of ethics in machine learning, the people have not been, unfortunately, thinking about this for long enough, and so it's something that's evolving. Right. So it's a topic that people are discussing. It's something that is being emphasized more in classes, but I would say not enough, and not necessarily in a kind of canonical way across different universities, or even across different courses, or across different individuals.
So you're also one of the original organizers and remain an organizer of a conference called MLSys or SysML.
No, it's MLSys.
MLSys. Okay. Yeah. And then so I think that for the most part, when we think of machine learning in academia, it tends to be people who are interested in models and algorithms and things like this.
Right.
So this conference is in many ways, I think, kind of following the trend in industry of more of the machine learning engineer, right? So.
Yeah, I mean, so it's definitely it's definitely work at the intersection of machine learning and systems. And there's definitely a strong industry component, but it's very much a research conference. Okay. It's the kind of the inspiration for MLSys was largely, there were a handful, like the AMP Lab is one of the pioneers, along with a handful of other researchers at CMU and elsewhere, kind of bringing systems and ML people together in the early 2010s, and maybe before, to kind of think about problems at the intersections of machine learning and system. And that led to great success. That led to things like Spark and many other things. And right, that community has grown a lot. And so, it was definitely a struggle that as researchers, a lot of us felt, where we would do research that we thought was really high impact precisely because it was at the intersection of two different important areas. And it was problems that people hadn't really thought about before. But you would talk to the ML people and they'd say, no, that's actually systems work. You talk to systems people, they'd say, no, that's ML. So it was kind of like work that we thought was really high impact that also couldn't find a home, right? And as this field has grown more and more, it's been pretty natural to, there's a bunch of people who have felt this way. There's a big enough community and a continually growing community of researchers, again, many of whom are in industry, because a lot of the most exciting work is certainly happening in industry, but around kind of building systems for machine learning, as well as, less so, but there's some of this as well. People using machine learning for systems. There's been some really interesting work there. And while the work is very different, the intersection of expertise is very similar. But yeah, so it's been really neat to see kind of, we felt back in the AMP lab that we were doing things that almost nobody else was doing. And now there's kind of this big and growing community of researchers who are really excited about this stuff. It's been really kind of amazing to see.
But in many ways, this kind of cross-fertilization is necessary to get to your vision of democratization, right?
Oh, absolutely. I mean, it's sort of, and it's very much in line with what we're doing at Determined as well, in terms of to build any sort of machine learning system, whether it's at Determined or anywhere else. If you have just ML folks building this stuff, they don't have the expertise or the interest in designing kind of production quality systems. If you have systems people doing it, they're great at building production quality systems generally, but they don't have the domain knowledge of ML to understand how to design these systems for the end user, or not enough. So you really need these two groups of people to be talking to each other. Now there's a third group, which is the hardware folks, because there's this proliferation, right? So when we started thinking about it, it was more, software systems and ML. The hardware has come up more, and I think deep learning is a big part of that. But right now there's this proliferation of different hardware, and that makes things even more interesting, right? So now there's 3 different communities, all of which need to be able to talk to each other and understand kind of what the other is doing.
And with that, thank you, Ameet, and keep us posted as the Determined training platform gets more and more users. I anticipate there will be a user conference of some kind, right?
Yeah. I would say immediately, though, I would say call to action. We'd love more people to join the community. Slack, as we mentioned, is kind of the primary way to interact with the community. We are also sharing kind of a bunch about our short-term roadmap and design docs to get feedback from the community. So we'd love to hear from you if you're interested in checking out the product.
Thank you.
Yeah, thank you, Ben.